In this module, we're going to look at chemical reactions. Specifically, we're going to understand the evidence that we have a chemical reaction. There are several. First of all, a chemical reaction occurs when there is a change in composition of your material. That is the only thing that happens for a chemical reaction. Observations that can lend you to believe that a chemical reaction occurred are formation of a gas. If your process starts bubbling or a smell is created that was not there before, that is a sign of a chemical reaction. However, if that bubbling resulting because you are heating a liquid and that liquid starts boiling, boiling is a physical process, so that is not a chemical reaction. If a precipitate forms, and precipitate is a solid that happens when we mix non-solid materials. So if I mix two liquids together and a solid forms at the bottom, that is a sign of a chemical reaction. Production of energy. If heat, light, or sound is produced, that is often a sign that a chemical reaction has occurred. If there is a change in temperature, if the process gets warmer or colder with no additional input, that is a sign of a chemical reaction. Or if there's a change in color, if I start with something yellow and it becomes blue, if I start with something clear and it becomes yellow, that is a sign that a chemical reaction has occurred. All of these processes are just indications that a chemical reaction occurs. It is not proof of chemical reaction. Chemical reactions only occur when there is a change in composition, and usually we have to show this through notation. So notation of a chemical reaction, beginning and end are separated by an arrow. Substances written before the arrow are called reactants. In this case, the reactants are propane and oxygen. Substances written after the arrow are called products. So in this case, the products are water and carbon dioxide. Note the formulas at the beginning and the end are different. That lets us know it's a chemical reaction. If I have the same things as reactants and products, that is a physical change, not a chemical reaction. States of matter are indicated by symbols after the formula. We can use it S for solid, L for liquid, G for a gas. Sometimes our substance is dissolved in water, in which case it is not truly a substance, it is a mixture called an aqueous solution. But we would indicate then our reaction by putting an AQ after that. And if we do that, we are indicating that the water is not important, and it is only the material dissolved in water that is reacted. So it is still a substance, even though it is part of a mixture. It is a substance that we are looking at. In this case, the propane is a gas, the oxygen is a gas, the water is a liquid, the carbon dioxide is a gas. Coefficients are used to make sure there are the same number of atoms on each side, and coefficients are put in the front. So if we look at this, there are 3 carbon on the reactants, 1 carbon as a product. 8 hydrogen as a reactant, 2 hydrogen as a product. 2 oxygen as a reactant, 3 oxygen as a product. And this violates the law of conservation of mass, because we cannot create atoms, we cannot destroy atoms, we can only rearrange them. So we put coefficients in front. So now I have 5 O2s, 4 H2Os, and 3 CO2s in my reaction. And if I add all the pieces up, I can see that there are 3 carbon on the reactants, and 3 times 1, so 3 carbon as a product. There are 8 hydrogen as a reactant, and 4 times 2, or 8 hydrogen as a product. There are 5 times 2, or 10 oxygen in the reactant side, and 4 times 1 plus 3 times 2 is 10 oxygen on the product side. So we have the same number of atoms in all situations on reactants and products, so that is said to be balanced. We can visually represent our reactions as well by doing boxes to represent our container. Now, propane has 3 carbon and 8 hydrogen. So in this symbol, the carbon are represented by the gray spheres, the hydrogen are represented by the yellow. O2 is oxygen. Oxygen as an element occurs diatomically. So the blue spheres represent oxygen, and this is my O2. Water has 1 oxygen, which is blue from the previous picture, and 2 hydrogen, which is yellow from the previous picture. So our water would be represented by 1 blue sphere and 2 yellow spheres, as in this image. And carbon dioxide would have 1 gray sphere from the carbon and 2 blue spheres for the oxygen, so carbon dioxide would look like this. So these represent the different elements, or the different compounds that we have. Now on the reactant side, we need a total of 5 oxygen, so we would add 4 more. And on the product side, we would need 3 more waters, and 2 more carbon dioxides. So this now gives us our complete reaction in a visual representation. You're going to have to be able to recognize both visual representations and equation representations of chemical reactions. So this is our first module for reactions, evidence of reaction.